Hello, we are from Group 4 and we are going to present to you about design a PLC programming for process control with efficient and sustainable operation. As we know, designing implementation system for process control and automation of fluid filling operation demand a meticulous approach. The orchestration of valves, switches, timer, and relay form is intricate web of control mechanism that regulate the inflow, outflow, and critical timing with a fluid filling process. CS Programmer software emerged as a vital tool in this project, offering the testing, refining, and perfecting the system before real-world deployment. In process monitoring fluid and control of potential hazard materials, safety measures play a critical role in mitigating risk associated with automated system. The economic aspect of implementing process control instrument in the fluid filling process can be significantly impact the overall cost and efficiency of the operation.
Assalamualaikum, my name is Muhammad Syamil bin Muhammad Zainuddin. I will be presenting for the table of relay elements. So, for this part, we have 14 elements that we use in the PLC simulation, which is relay C1 input and relay C1 output, and the relay C2 input and relay C2 output. Also relay C3, solenoid S1, solenoid S2, timer 1, timer 2, float switch input, float switch output, timer water out, warning alarm input, and also reset button. And then this is for the truth table for the ring 1. So for the ring 1, we have a switch button, float switch, relay C3, relay C1 input, and relay C1 output. For this ring, the input for switch button should be 1, float switch should be 0, relay C3 should be 0, and relay C1 input should be 1, so as the output will be 1 because the switch button is normally open, float switch is normally closed, and relay C3 is normally closed. As for the ring 2, we have relay C1, float switch, relay C3, and solenoid. So for relay C1, it is normally open and float switch is normally closed. As for relay C3, also normally closed. So in this case, for the output to be 1, the relay C1 should be 1, float switch should be 0, and relay C3 should be 0. As for the ring 3, we have solenoid S1, timer 1, relay C3, float switch input, and float switch output. For solenoid S1 is normally open, timer 1 is normally closed, as also relay C3 is normally closed. For float switch is normally open, so the input should be 1, 0, 0, 1, so the output will be 1. As for ring 4, we have only 2 input, which is float switch and also relay C3. As for the timer water is for the output, so in this case the float switch should be 1 and relay C3 should be 0, as relay C3 is normally closed. As for rung 5, we also have 2 input, which is float switch and timer 1. For the float switch is normally open, as for timer 1 is normally closed, so the input for float switch and timer 1 is 1 and 0 respectively, so as the output warning, which is warning alarm, will be 1. As for rung 6, we have 4 input, which is timer 1, timer 2, relay C3, relay C2, and the last one is relay C3 output. So for this case, we have timer 1 normally open, and timer 2 normally closed, and relay C3 is normally closed. As the relay C2 is normally open, so the input should be 1, 0, 0, 1, so the output will be 1. As for rung 7, we have 1, 2, and 3 input, which is relay C2, relay C3, and timer 2. Relay C2 should be 1, relay C3 should be 0, and timer 2 should be 1, so the output, which is solenoid S2, will be 1. And for the last rung, which is rung 8, we only have a reset button and also relay C3. As for this, it should be quite straightforward, as whenever reset button is 0, relay C3 is 0. Whenever reset button is 1, relay C3 is 1.
My name is Nur Faralana binti Samburi. My metric number DE210111. I will demonstrate the PLC simulations. So first, I will run the simulations. Okay. When X1 is pressed and depressed, so give the value 1 to press, then immediately give the value 0 to depress. So the relay C1 will be energized. In round 1, the relay contact C1 close and energizing the solenoid S1, which is allow the fluid to flow into the tank. In round 2, solenoid S1 energize and trigger the float switch. In round 3, float switch energize and trigger the timer 000, which is the timer 1 that operate for 120 seconds. In round 4, float switch trigger and causing warning alarm to activate due to the chemical reaction occurring in the tanks. So it will count for 120 seconds and warning alarm will be on. So next. In round 5, after 120 seconds, the relay C2 energized. In round 6, the relay contact C2 close and producing two output, which is timer 001 and solenoid S2, which will be triggered for 90 seconds. Solenoid S2 allow the fluid to flow out of the tank. So when I run, after 90 seconds, the system will return to its original positions. In this system, two safety aspects have been inserted into the PLC design. The first one is the reset button. The reset button can be pressed for ensuring a quick response to any unexpected situations. For example, when I press the start button, so next, when I press the X1, the entire system cannot be activated. Next, warning alarm. Warning alarm will be activated when the chemical reaction occur in the tank, because we know that chemical is hazard. Then by insert the warning alarm into this system, it will notify the current situation, especially to workers.
My name is Nurali Hanisan Timisan. My matrix number is DE210086. Next, I will explain about process of the additional safety on design PLC. The first one is reset button. In PLC, which is programmable logic control, a reset button is often used for safety purpose. It allows operator to quickly stop or reset the PLC in case of emergency or abnormal situations. This also helps to ensure the safety equipment, process, and personnel by rapidly interrupting the control logic and stopping potentially hazard operation. For additional safety number 2 is warning alarm. This function aims to enhance safety, efficiency, and responsiveness in the working environment by promptly notifying worker about critical process conditions. It can alert all workers when want to provide chemical at the tank. Next, we go to the simulation of reset button and warning alarm. So, This is the process of the reset button works. To press the reset button, we need to put value 1 and then the reset button will be on. Next, we need to press the start button X to see the whole system works or not. After we press the start button X1 and put value 1, it can see that the system are not works and all the system will be off when we press the reset button. So it can see the system not function at all. Then if we want to see the reset button off, we put the value 0 and we can see that all system will be works as usual. So the function of reset button is same as emergency button. Next, it shows the process of warning alarm in the whole system. If we want to see the function of warning alarm, we need to press the start button at X1. We'll put the value is 1. After that, put value 0 to stop the timer. Why we put warning alarm at timer 1? Because it want to notify the all worker that we want to put chemical at the tank. So it more safety because all the worker will be alert with warning alarm that provided and ringing.
Okay, next is about safety aspect of process control instrumentation. First one is emergency shutdown mechanism. Emergency shutdown mechanism like reset button is a critical safety features designed to rapidly stop the entire process in case the hazardous situation and when predefined condition indicates the imminent danger. Second is alarm system. Alarm system serve as a early warning mechanism, notify operator about deviation from normal operation condition and potential issue within the process. Third is about safety interlock. Safety interlock mechanism integrate into the control system to ensure certain action are only allowed under specific and safe condition. And fourth is safety instrument system, SIS. SIS is independent specialized control system designed to protect against the mitigate hazardous event. They are distinct from the main process control system that and are dedicated to handling safety critical function. And last one is fail safe design. Its principle is important to ensuring that when component or system fail within the process control setup, the default to state minimize risk and ensure safety.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ihsan bin Isham with matric number AE200032. Okay, today I'm going to explain about the economic aspects of process control instrumentation. So we have four approach in order to achieve the cost effectiveness in process control instrumentation. For the first, we use the life cycle cost analysis. So this method invests in better quality equipment which may cost more upfront but we save you money over time because of its increased longevity and dependability. It helps it also helps company to make decision by weighing options according to how they will affect their bottom line over time. Besides it, through the assessment of the overall cost of ownership, organizations can pinpoint avenues for optimizing investment. And lastly, it takes social environmental implications into account in addition to financial consideration. And the next approach that I want to explain is automation and integration method. So this approach can lead to streamlined processes, reducing cycle times and improving overall productivity. So this method consistent and precise control can achieve through automation result in higher quality outputs. The predictive maintenance and real-time monitoring will prevent unexpected failures, minimizing downtime and associated costs. So the automated system can also help in maintaining regulatory compliance and enhance workplace safety through control and monitored operations. Okay, so for the third approach is energy efficiency. So by selecting devices with higher energy ratings such as motor, sensor and control system designed specifically to optimize energy usage without compromising performance. So the process optimization involve minimizing energy usage without compromising productivity by modifying operational parameters, enhancing control algorithms and making sure systems are working at peak efficiency. Consider upgrading outdated equipment or retrofitting existing system with energy efficient components. Maintenance and also calibration are important to ensure equipment run as efficiently as possible when it receives routine maintenance. So for the last approach, which is predictive maintenance and remote monitoring. So anticipating failures means scheduling maintenance during planned downtimes, reducing unexpected disruption and production health. Preventive actions cost less than reactive emergency repairs, optimizing maintenance budgets and also extending equipment lifespan. So this approach will immediate access to data and analytics allows for faster decision making, reducing response time to issues. And lastly, the yearly identification of issue and remote troubleshooting can often resolve problems without the need for physical intervention, reducing travel and on-site maintenance costs.
Okay, in conclusion, in design and simulate optimization system of fulfilling process control using SCX programming software not only ensure the precising and reliability of automated process but also allow for true testing and optimization before real-world implementation, ultimately enhancing operational efficiency and system performance. That's all from us. Thank you.